Let's see if you, oh, I think it's. All right. So you are here if you're in my name is Justin Hill, and you are here if you're in my online statistics class for fall 2025. And let's get this rolling. Um, so we're here, kind of you're here in this class for 16 weeks to talk about statistics. Um, so I think a good question, you guys already had it in your orientation module. There's a page that said, what is this class about? It kind of gives you some ideas. And you guys even answered a syllabus question. I think pretty sure you had a syllabus quiz question that was maybe 3 topics that this class is about. So, but instead of those, I want to talk about, we want to start out today with just kind of like, okay, we're learning statistics, but what in the world is that? What in the world does that mean? So statistics is sort of, I would say, the math and art. We'll see there's a little bit of art to it actually, but the math classes you've seen probably before this was some sort of algebra class. Um, in algebra, we have an equation, we have an expression, etc. We plug in a number and we do a calculation and we get one answer. And with equations, we solve for a variable and we usually get one answer, right? So everything is very what we call deterministic. Everything is very determined. There is maybe there's multiple ways to the right answer, but there is a right answer. You're going to get it as long as you know how to do these the steps for the problem, or at least you understand the concepts and ideas behind algebra and use those as tools to get to your answer. Um, but that's in general. Algebra is about equations and expressions that we either calculate, we solve, or we graph. Um, so it's about taking something logical and kind of functional and getting to the end of the process and getting the answer. Statistics is a different beast. So one of the things you'll see, honestly, as we go through this class, I will say honestly that the math in this class is easier than you had in an algebra class. And I promise you guys that. The math is actually easier. What statistics is about is instead of equations, expressions, etc., we're going to use equations in this class, but that's not what this class is about. Instead of equations, expressions, things you got to solve, statistics is about data. So oftentimes, whether you're running a science experiment or you're trying to figure out something, if you're a sociology or psychology major, you're trying to figure out something, trying to figure out something going on with a trend in, culture, humans, countries, with how people behave in a work environment, with how people behave interpersonally in different relationships, etc. All the way to finance, how the market behaves, etc. When you study things like that, sometimes you get equations with one deterministic answer. But besides, honestly, your what they call hard sciences or high sciences, physics and chemistry, all these other things, biology, psychology, sociology, um, economics, etc. You actually rarely have an equation for what's going on, but what you do have is you have some sort of experimental setup that gives you a bunch of data. So like I said, it gives you a bunch of data. It gives you a bunch of data about trends in culture, trends in, views on TikToks, etc., something like that. It gives you data for, again, just kind of trends in people's behavior in one country versus another. It gives you trends in the market, etc. That information, when it's given to you, is just a bunch of data. It is not an equation, it's not an expression, it's a bunch of information. And so what statistics is about is how do we organize and visualize and then eventually analyze that data? That's really what this class is about. So you're given a bunch of data about some situation. First of all, how do you organize it? And we'll kind of talk today about why you even need to organize it, but how do you organize it? How do you visualize it? How do you make a picture out of it? And we'll kind of talk about why we make pictures out of it, actually. There's really good reasons for that. It has to do with psychology, also just humans, just the way we are. But I want you guys, I don't want to say it right now. I want you to kind of stumble into it, kind of discover it as we go. Um, but we usually need to visualize that data and then we need to analyze that data, right? So, company that owned TikTok wants to analyze those trends in videos so it can kind of push its influencers to do certain types of videos, right? So that increases the profit, the top end on them, increases the top end on the influencers. So it's kind of a win-win for everybody, right? So they want to be able to sort of in real time analyze and predict, what types of videos, et cetera, are going to be a better play going into the future, are going to get, a little more views and therefore a little more profit. Um, in economics, same thing in the stock market. You want to be able to analyze before it happens, kind of where the trends are. Um, and again, psychology and sociology. So that's maybe not psychology and sociology is usually not about future looking, but it's about looking at the past and then forming some sort of conclusion about human nature or the nature of people together in groups, right? But still, you're given a bunch of data out of some psychology or sociology study, and you want to maybe analyze, what's again just what are better ways to resolve conflict, for instance, in marriage, right? Or you want to analyze what's a better way to deal with crowd control when there's a large amount of people, right? What are, just kind of better techniques to do that? So yeah, so eventually we always want to get to analysis of the data and kind of that telling us some conclusion that will help us kind of be better about things essentially. Um, like I said, when it's economics and stuff like that, they just want more profit. They just want more money. But when it's psychology and sociology, we're trying to analyze just how to be better about things as humans, right? Um, so organize, visualize, analyze. That's what statistics is about, taking data and doing those three things. So we are in this first two chapters. These first two chapters will sort of make up the first test that we're going to get to. I think it's sort of towards the end of this month, towards the end of September. Um, those first two chapters, we're actually going to see a lot of organizing, a lot of visualizing, and a little bit of analyzing. As we get later on in the course, though, we're going to do a lot more analyzing. So you'll see that basically the back half of this course is all once we have a good idea how to organize and visualize the data, it's all how to analyze it rigorously. So these are things. And so yeah, like the back half of the course is that because it's that important, basically. Because these are things that you guys are going to see in your major. So if you're a psychology major, you get to your third or fourth year, you're in a class where you're analyzing these studies and the conclusions that the researchers are coming from. And you both want to, it's like, so you want to know how to analyze the data and the results and the studies that you're looking at, and confirm their analysis, because you would assume that if it's published research, it was done correct. And I would say probably 99.9% of the time it is, but occasionally there's mistakes. Or maybe you look at their research and you look at it and you say, well, okay, I understand how they set up their experiment. Their conclusion is correct for what their experiment is, but I actually think the experiment should be set up this way, or I actually think they were looking for the wrong thing, and this is the thing we should be looking for, and this is really what we should be analyzing. Again, so those are things that you're going to be doing in third and fourth year classes for psychology and sociology, and making your own conclusions, which it's either a summary, it buttresses the researcher's conclusions, or you have some sort of rebuttal or some sort of yes, but things could be done differently, or we could make this the goal and this would be a better play. And then by the end of your major, you might even do your own research. In fact, that's usually the goal. By the end of your major, at least once, you should have one class where you do your own research. You set up your own study, you set up the whole experiment, you get a bunch of data, and you do the analysis. And you organize the data and you make a picture of it for everybody who's going to read your results, so they understand why you kind of concluded what you concluded, but then you make a conclusion off of that. So you do that in psychology and sociology, even in economics, maybe a little less. Usually economics is just more a bachelor's bachelor's degree for economics is focused a little more on just kind of being able to understand the ideas behind all this market analysis and where that comes from. But you're still going to be in classes where you've got to analyze their analysis. You got to see, did they get the correct analysis off their data? Again, maybe they did, but you think it should be painted in a different direction, or you think that they should have set up the experiment differently, or they should have analyzed something differently. So the same type of things. So you see this in a lot of majors. So what I'm trying to say is this class is not just something for you to pass. It's something that you're going to see later. It's something you're going to have to do even in what I would call some of the softer stuff. So maybe, well, again, even especially if you're a biology major, you're going to be end up doing some research projects where you have to do the analysis, but you're also going to be end up in a lot of classes where you're studying biology and there's some analysis that has been done and you got to be able to read that analysis and know why it's correct, right? Or make sure it's correct. Even something as innocent as nursing, right? You're never going to have to do a project. You're never going to have to do some sort of study on a bunch of patients and get data, but you are going to be reading a shitload of those. And they're going to be giving you their analysis. So you're going to be reading through this textbook or reading through this article or whatever, and they're going to have a very rigorous study set up. And then they're going to say, this is my data. And then they're going to say, this is the picture I got out of it. And this is my result. This is my analysis, right? You got to be able to read that. And so that's what this class overall is about. I want to prepare you guys to receive data, organize it, visualize it, and then be able to analyze it because you're going to be doing that in all your majors at some point. And don't even mention if you do end up going on to a master's or a PhD in any of these degrees, graduate degrees are analysis. So even if you don't do a ton of analysis in your bachelor's, if you're thinking about getting a graduate degree eventually, just know that every graduate degree is about analysis. You actually doing a study, you actually analyzing. That's every graduate degree. So definitely by the time you hit there, everything that we learned in this class, especially the back half of this class, the analysis part, is going to be really important for you to kind of pull back up. So anyways, so that is kind of what this class is about, the use of this class. Like I said, literally the first couple chapters, we're going to do a lot of organizing of data. We're going to do a lot of visualizing of data, a little bit of analyzing. So let's start that. This lecture is going to give you enough so you can do section 2.1, the section 2.1 homework. So I'm actually going to, I'm going to turn this on. So I'm going to pull up one of the problems from 2.1. So the way I'm going to do this is I think the best way to do this is not just like give you some homework problem, but what I'm going to do is, like I said, statistics is about, I give you data and you do, you organize it, you visualize it, you analyze it. So we're doing a lot of organizing and visualizing. So let's start by, I'm just going to give you some data and let's kind of talk through how we would start to organize this data. So something like that. February, something interesting. I guess let's look at something like 13 to start with, but let's take 13 as sort of, I'm giving you some data and let me look. I think I need to move y'all's camera over just a little bit. So it is. Oh no, you can kind of see that well. What you can't see well is though you're getting this infinite hall because of the effect of this. Give me a second, let me remember how to get rid of this infinite hall. Infinite reflecting mirrors. Let's see. I just gotta pull this down. Let's see if that. Yeah, okay, I just gotta keep this down. Yeah. All right. So this is a relatively benign example, although for the phrase they say first world problems. For living in the first world, this is actually stuff we collect data on because at best it's the most benign, morally best thing is that there's some curiosity. What flavors? I think these are flavors of coffee do people prefer? Um, but that's the most morally, it's just benign. It's just pure interest. But more than that, it's Starbucks, Pete's, whatever, Dunkin' Donuts wants some analysis, wants some data on flavors that people tend to like, so that when they pitch their newest drink, it centers around things that more people are going to buy. When they stock, when the manager stocks the what do you call it? Yeah, when the manager stocks the supplies, the syrups, they want to know what do they need to have more of because more people are going to tend to use that flavor in their drink, their coffee or their drink or whatever. So this is kind of first world problems data, but nonetheless, this is something that especially businesses would be very interested in. So this says, so a survey was taken asking the favorite flavor of a coffee drink a person prefers. The responses were, you can probably guess these. V is vanilla, C is caramel, M is mocha, H is hazelnut, and P is plain. And then we'll get to the question. But so actually, before you even read the question, so I don't want you to get tripped up on some of the vocabulary. We'll talk about the vocabulary as we go, but I actually don't want you to get tripped up on the vocabulary first. So I don't want you to read the question yet. Or if you have, just pretend you didn't read the question. But I want you to see that again. So you do some type of survey like that. Everybody marks what their favorite flavor is. What you get back is a bunch of papers, right? Or now you get back a bunch of responses on some web app. But nonetheless, this is still what you get back, whether it's a bunch of papers or a bunch of responses on a web app. You're just going to get a bunch of V's, C's, P's, M's, whatever. It's just this is a block of data. So this is what data looks like. Let me remember some vocabulary. So there's some vocabulary that they're going to use as we go through. So I just want to make sure to kind of say it. You'll see as we go through that this class maybe more than others, like you definitely need to see some vocabulary, but even still, so me as a teacher, I really don't emphasize vocabulary because oftentimes you get lost in the word because there's sort of a right word to use and you want to know the right word and what it means and when to use it and where to use it. And if you think about that, you're using a ton of computing space in your head for the right word rather than really how you get through the problem, right? Or how you give them the answer that they're looking for. So to me, vocabulary is great, but it is a waste of computing space in your head, basically. So know the right words so that when the problem uses the word, you know what they're talking about, but know the right word only for that purpose. Words are language, words are language. But language is about communication. It's about me and you in the book, whatever, me and you understanding exactly what each other are referring to. So know the words for their reference so that when you see it, you know what they're talking about, and don't waste any other computing space in your head on those words. Let the rest of it be about actually, working through the problem. So this is a block of data. Now, this class always works better when I have students here because you'll see as we go through, I tend to ask a lot of questions because I think it helps you. Not only I know it helps you not only get the concepts and grab the material that we're looking at. It helps you really learn not only the ideas but what we're doing. If I can ask you questions and then you think about it and you respond. And the thing is, whether you're right or not, that's actually not the point. The point is you taking the idea or the thing we're looking at apart and doing something with it. And by doing something with it, you're starting to analyze and figure something out about it. And then if you're wrong, you get to compare it to what I'm saying and just kind of, basically be like, okay, no, that didn't work that way, but it works this way. And you put those puzzle pieces together in your head. Or if it's right, it just reinforces, oh, okay, this really is the way to do this. Either way, that is learning. So I can get you guys to learn a lot more if I ask questions and you respond to them. Now, this is an online class. I'm just doing some lecture to a camera. So I'm going to do less questions probably than I normally do, but I'm still going to do that. So what I'm going to do is I'm going to ask you guys questions. And even though you're not here to respond, I'm actually going to pause and sort of give you space for you on the other side of the computer to be a crazy man or woman and actually talk back to the computer. So when I ask those questions and I kind of pause and give that space, what I'm saying is I really encourage you guys to actually answer like you were in class. Um, don't worry, you're not crazy. Nobody's looking at you like you're crazy. Just take the questions I give and take a second, think about it, respond, and then kind of compare it to, to what I'm saying after that. So I will physically take time. I will actually pause. And then even on some of the problems we're going to do, normally what I would do in class is I would give you guys time to work on it and then we'd come back to it. So you'll see what I'm going to do is I'm literally going to ask you to pause the video on your side and I'll pause it on my side. So to sort of simulate that of, again, I don't want you to just watch this video through. You're not going to learn, you're going to learn maybe well from that, but you're not going to learn best from that. If I give you a problem or something to work on, you should stop the video, work on it yourself, do your own thing, and then run the video from there and then compare it to what I'm doing. And again, you'll see most of the learning is about compare contrast. So you look at what you did that worked, you look at what you did and that reinforces those kind of pathways and puzzle pieces. And then you looked at what you did that didn't work and you figure out why it didn't work and you figure out what works and why. And that makes a really strong connection. That's actually where most of your learning happens, from getting things wrong and figuring out why they're wrong and then figuring out what's right and why it's right and kind of comparing the two. That's actually where most of your learning happens. So anyways, so I'm going to ask you guys to pause when we have give you problems to do. Please actually do that. Don't just kind of run the video through. So anyways, okay, so this is a block of data. So my question to you guys is, again, forget kind of the question they ask here. Just think about the situation. So you're a manager at Dunkin' Donuts. So put yourself in the situation. You're a manager at Dunkin' Donuts. You want to know what syrups are best to stock. You don't want to kind of run out of something that you really need. You also don't want to have an oversupply of something that's people barely ever get, right? So you're a manager at Dunkin' Donuts and you send this survey out to everybody. What's your favorite flavor for your coffee drink? And this is the information you get back. So my question to you guys is, how useful is this to you? Does this tell you much of anything? I'll give you guys a second to think about it and kind of speak back at the screen. So good. Notice, and so what do you guys think? How useful is this? And some of you might be saying, well, it's at least something, right? It gives me information. And that's true. I think a lot of you are probably saying this is not really useful at all because, yeah, it gives me information, but right now, this is just a bunch of letters and I can't really do any analysis with it. So my point as the manager is to figure out, which flavors do I stock the most and then second most and third most. But this block of things doesn't really tell me that. Like I could figure it out from that, but as it's presented, literally this block of information does not tell me what to stock first, second, third, or fourth. So do you guys kind of see that? So this is where I'm saying the first thing in statistics is how do you organize data and how do you present data? And this is why we have to do that first, is because the interesting thing about data, data gives you a ton of detail. So again, the first response you may have thought is, at least I got something out of my responses, right? It gives me the detail. So this is a crap load of detail. I can't analyze shit with it. I can't do anything with it, right? So we need to have a way to organize the information and then even a way to maybe picture the information so that I can analyze and do something with it. So that I can say, okay, I'm going to stock, I'm going to stop this, what do you call it? This syrup the most, this syrup second most, third most, etc. So that's why statistics kind of is the way it is. It's like we don't make pictures out of it just because it's nice or because we think it's cute. Some of it is going to be cute, but it's because data by itself is almost useless. It gives you a lot of detail, but you have no way to analyze anything. So we need to organize this data, and we need to make a picture out of it. So if you think about it, that is kind of, even if you're not given a question after this, if they just say a survey was taken and here's your information, in the situation, the purpose of this. The purpose of this is I need to know what happens the most, second most, third most, etc. I just need to know the order, preferences that people have in these. So if you think about that, if I'm trying to figure out what happens the most, second most, third most, what I'm doing is I'm counting how many people picked vanilla, right? I'm counting how many people picked hazelnuts, caramel, etc. And there's another word that we don't often use for counting, and that word is frequency. And so what we can do naturally from this, so they call it a frequency distribution, or I call it a frequency table. But what we can naturally do from this, if I need to analyze this data and figure out what's first, second, third, fourth, I need to go count my V's, my C's, my P's, my M's, etc. And so we can go count them, and counting something tells you the frequency. Frequency is just just a fancy word for counting. How many times does this thing happen? And I can put this information in a table. So I'll have one column in my table that says flavor. And then the second column is going to be the frequency, or the count. And so again, I call it a frequency table. They call it a frequency distribution. It's the same thing. The distribution is just a fancy word for it. So we're going to make a frequency distribution. That's what they have here for this data. And it's just a table where you mark your categories for, in this case, this data we're looking at. And for each one, you count out how many times it happens. Let me see too. So different books do include some extra rows on these tables. So let me see. Yeah, maybe we can talk about that. We don't really need it right now, so that's fine. So that's what we're going to do. We're going to make a frequency distribution, a frequency table. So the first thing you're going to do is I'm going to write out the categories of my data. So the other thing about this data, the other bit of vocabulary you need is data comes kind of in general in two different ways. Data sometimes comes like this, where you pick a category, right? So essentially, one way to think about it is you're picking words. But it's not always words, but most of the time it's words. So you're picking some category. And so they call this categorical data. There's another word for it. Give me a second. So you'll see, I don't even remember all the vocabulary for this, because the vocabulary, one, it's redundant. What you guys won't see, just because of your experience in mathematics and not having seen a bunch of these textbooks. So one of the interesting things is the words they've used for this has changed over the years. So the words I learned for this in the 90s and 2000s in high school and college, a couple of the words are actually different now in the textbooks. Is the idea any different? No. They just decided that they wanted the official word to be slightly different. So know that happens even in mathematics. It happens more in statistics than it does in algebra, but that happens a decent bit in mathematics. But give me a second, sorry. I'm looking for a particular word here. So let me see if I can find it. This word. Well, instead of sort of wasting your time, so I'm actually going to pause on my side. Let me find this word really quick. Hold on. I found the word I was looking for. And yeah, I got to move that. But so they'll call it categorical data because you can split it into sort of these categories that are usually words or some sort of adjective, condition, etc. Or they'll call it qualitative data. So data that is given to you, like basically data that's a quality of something rather than a measurement of something. If it's a measurement of something, we call it quantitative data, and I think there's another word for it too, which I can't remember right now. But quantitative, it tells you the quantity, the amount, right? So you've measured something and there's a number that goes with it. Qualitative, you've measured something or given a survey, like in this example, and they give you a quality, a category, etc. Um, so let's go back to the problem though. So let's actually get this. Let's get this frequency distribution, this frequency table made. So I'm gonna write down the categories for the flavors, and then I'm gonna count these up. So for instance, here we know the problem tells us the categories are vanilla, they are caramel, they are mocha, they are hazelnuts. Hazelnut is the best one, by the way, but not everybody agrees with me on that. That's probably a lot less people like hazelnut usually, but hazelnut is amazing. And then plain. So plain, you can think about it as almost like no flavor, right? So if, like, again, this is categorical data, but if you could think of it almost like quantities in some sense, it's like plain is zero flavor, and then these are just other varieties of flavors. But, all right. So then to complete my frequency distribution or my frequency table, I just need to go through and count the number of vanillas, number of caramels, mochas, hazelnuts, etc. So I'm actually going to have you guys do that. So I'll have you pause the video on your side. I'll pause it on my side. Go ahead and work this through. Count them all up, and then write the amounts here in your frequency column. All right, let's see what you guys got. Let's go back to the page. Where should it's the right place. Okay, good. So we had to go through and count the number of vanillas. So what I see is in the first row, I've got 1V, and then 2, and then 3, and then 4, and then 5, 6. I see 6 vanillas. Honestly, it's surprising. So 6 out of 24. They said this was actually, how many did they say the responses were? Blah 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 blah. Actually, they didn't say how many, but it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 5. So it looks like we have 50. So to me, this is actually surprising because I feel like whenever I'm at a coffee shop, I love coffee shops. Whenever I'm at a coffee shop, vanilla is probably the most chosen thing. Most people love to throw vanilla into something, or they buy the drink that is vanilla, blah, 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 latte or whatever. Um, so we'll kind of talk about, I look at this and I say, this is surprising, but this is, presumably this book is good about, I think most of the stuff that they give you here is actually real data. It was some actual study done or some actual data that you can see and get other places. In fact, a lot of these you'll see, like on 14, you'll see says all of this stuff they give you says based on information from the UCLA Internet Report. So this book is really good. One of the reasons I like this book and the system a little better than others, but especially the book, is that it really uses real data. It doesn't just sort of make up stuff to give you things to, that you can work on. So anyways, so we'll kind of come back at the end and maybe talk about this 6 out of 50. By the way, now that I know there's 50 pieces of data, that also helps me with this frequency. These should add up to 50 by the time we get there. All right, so then caramel. I see 1 caramel, 2 caramel, 3 caramel, 4 caramel, 5, 6, 7. So I see 7 caramel. And people do like their caramel. I hate caramel. I just don't like the flavor, but I know a ton of people like caramel. And then M is mocha. So this is the one that is showing up a lot. So basically chocolate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It's like 22. So a ton of people like Mocha. Now, this is the interesting thing too. So again, I'll kind of talk about these things as we go. And this is where we'll get to eventually in this class is, as you get this data, you want to analyze it. So this is an interesting result to me because so basically this, I think the good question about this bit of data is where did they do this survey, right? So eventually as we go through this class, we'll talk about the experimental design of stuff and just kind of like making sure that things are random but also representative of, if you're trying to get this data and analyze a result for America versus a certain state versus a certain city, etc., how would you collect that data so you can make sure that it is random and not biased, but also kind of covers, gives you a good representation, a good cross section of the population you're trying to figure this out for, right? So this is curious to me because yes, I grew up in Florida, back on the East Coast, a ton of people get mocha flavored things. But I've actually found since I've been in San Antonio that a lot of people here do not like mocha stuff. It's actually hard at some coffee shops to actually find um, not a mocha latte, but a true mocha. So a true mocha has more chocolate, more espresso, less milk than a mocha latte, which is what they serve at most coffee shops here. That's what I found in San Antonio. That's my own sort of, I can't call that science. I haven't collected data and done any statistical analysis that we're going to do in this class. But just, yes, my experiences going around. Um, this data is not from San Antonio. People don't seem to like mocha too much here. All right. H was our hazelnuts. So let's see how many of these we find. I see 3 total. So like I kind of said at the beginning, I love hazelnuts, but that is pretty consistent no matter where I've lived. A little more on the East Coast, people like hazelnut, but in general, people don't tend to like it very much. And then P is plain, so no flavor in it. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, really quick, I want to make sure this adds up to 50. So that's 13. That makes that 35, 38, 50. Yes, that's correct. All right, good. So this should be our frequency distribution, frequency table for this data. So tables, frequency tables, we'll kind of talk about as we go through these first 2 sections. A frequency table, all it does is organize my data. But it's very effective at doing that. So now again, my original question to you is, again, you're the manager of this Dunkin' Donuts. Which flavors do you buy? This box of data, doesn't really tell you anything. Notice though, this table tells you a hell of a lot. So just by organizing the data, suddenly you as a manager know exactly what you need to buy first, second, third, fourth. Obviously, wherever this is, you need to definitely major on mocha. You need to get a lot of those kind of chocolate, a lot of that Hershey's dark chocolate syrup or whatever. And then next level is maybe vanilla and caramel in equal amounts. Now, in this section, in this chapter, we're not going to start talking about, again, what some of the stuff I was just mentioning. So how this survey, okay, that's good. Now we've organized the data. We can see, notice that this organizes the data, this frequency distribution. It also is a picture of the data. So we're going to look at some pictures that are more picture-ish, that are more shapes and stuff like that. But this is actually a picture of the data. So again, organize, visualize. This gives me a very clear visual of the data, actually a very nice visual. Um, um, but the bigger question is this survey, was it done right? Is it representative of, is it a good cross-section representation of the people that are walking into this coffee shop, et cetera? And if you set up the experiment right, it will be. It'll be a good cross-section. So as the class goes on, we'll talk about sort of ways to go about setting up, collecting this data so that you do get something that's a good cross-section. We will assume, since this data has been given, that it is, a good cross-section, so. Good. All right, so for categorical data or qualitative data, again, once you're given the data, they're gonna say, make a frequency distribution or frequency table out of this thing. And that's all you gotta do. So yeah, that's the point that's the other point I was thinking of that I wanted to make really quick. So notice all I did was good old kindergarten counting out of this. And so I say that not even in like a diminutive way, like like what I'm saying is don't overestimate what you need to do here. You just need to count. However, that works well for you, but basically, you don't need to do anything more complicated than kindergarten on this particular, this particular problem. Um, let's see. Um, look, do they not really do this section? It's really interesting. Maybe that's a section. It would- All right, so let's start building some frequency distributions or frequency tables for not or qualitative data, but quantitative data. So something like number 15 here. And I want to do several of these because once you start doing it for numbers, for quantities, there are a couple things that come up with in terms of building your frequency table. So this one says a survey was taken of 50 individuals. They were asked how many days per week they ate at a fast food restaurant. So this one is going to say construct a frequency distribution using 8 classes. So we're going to start again, give you guys some vocabulary as we go. Based on the distribution, how often did most people eat at a fast food restaurant? So we'll get there. So this one asks you a little bit, literally basic analysis at the end. Write the table out, and you notice that once you write the table out, it's going to be very obvious which one happens the most, right? So they're just going to ask you which one happens the most. But I want to talk about some of the words they're using here. So they can say construct a frequency distribution, frequency table. They say using 8 classes. So I want you to think about, again, what I'd actually like you to do is, talk about what this word classes mean, but let's forget that word for now. So let's look at the data as it's given, and let's think about how we would do the same thing we just did for the previous problem. So they still want the same thing overall. They want a frequency table, a frequency distribution. So again, you ask 50 people, how many days a week do you eat at a fast food restaurant? And those 50 people gave you these results. Now, again, I want you to notice. So again, my question to you is, so how useful is this data given this way? And again, not horribly useful. I mean, at least now we got numbers. It's a little easier, maybe a little easier to see repeats and stuff. So this question, how often did most people eat at a fast food restaurant? You might be able to look at the numbers there and maybe make a guess at that, but that's about the best. There's no way to really analyze this data well when it's given to you as just a box of numbers, right? So again, we need to do something with that box of numbers. We need to organize it, visualize it in some way. And so for this section, the way we're going to do it is these frequency tables. Now let's think about on the last problem, they asked 50 people what their favorite flavor was in the coffee. And the flavors then were sort of our categories, or so these categories, another word they use for them is classes. Um, so, and sort of don't ask me why they use the word class for that, but it's sort of like a sort of, I don't know, class is just another, it's a fancy word for category, honestly. So it's a class of objects, right? It's a category of objects. It's a type of objects or something, something like that. So they call them classes as just a fancy word for category. So the category or the classes was very obvious from the problem because it was just flavors. This was qualitative data, quality, category, categorative data. It essentially, literally, the data tells you the categories you're looking at. Now, looking at this data for 15. So this is 50 people, each of them telling you the number of days they eat out at a fast food restaurant. What are the categories for this data? What are the classes for this data? And again, forget that they suggest doing 8 classes. Just think about this naturally. What would your categories or classes be here? So I think naturally here, looking at this, this problem at least sort of has some natural categories. So I think the difference that I want you to see here is once you have quantitative data, your categories are not as apparent. Qualitative data, your categories are just what the qualities are. It's what the categories are. So your classes are easy to figure out because you just write you literally write the categories of the data and then you just go count. But once you have numbers as data, it's a little harder. It starts to become a little harder to think about, well, what are my categories? What are my classes? Now, I think for this one, it's kind of obvious because if you think this one at least has some obvious classes, and we'll see as we go, you don't always have obvious classes. But this one at least has some obvious classes because the question is how many days, the question on the survey is how many days do you eat out at a fast food restaurant, right? So in some sense, the only possible answers are 0 days, 1 day, 2 day, 3 day, 4 day, 5 day, 6 day, 7 day, right? So we have 7 days in a week. So there's sort of the numbers that this that people would give to you that they would answer in this survey already fit some natural categories. And so when you're given data like this, where there's already sort of a natural category that fits, those are going to be your classes or your categories. So like for this problem, so for 15, that was 13. So I'm going to change this column. Well, I didn't want to erase the whole thing, but that still works. So this column is now days per week or number of days. You can just call it number of days, but it's the days per week that somebody is eating fast food. And the categories are naturally, so even if you didn't see their suggestion here, even honestly, if you're not looking at the data, number of days that I can eat fast food every week is either 0, 1, 2, etc. So again, when you have sort of natural categories, those are the categories you're going to want to use. So these would be my categories or my classes. So just again, know that class is another word for category. And honestly, for me, depending on the problem, I just kind of use which word makes a little more sense. I like the word category. It actually explains what you're looking at a little better, but we'll see as we get to some other problems. There's some other problems where basically, so some other problems where we're using numerical data where there isn't obvious categories, then class is maybe a better word in that moment because it just becomes becomes a catch-all, kind of a utility word. Anyways, so I can either eat fast food 0 days a week, 1, 2, 3, all the way down to 7. And again, my frequency just distribution just has frequency over here, and I'm gonna go count these things out. So let me have you guys do that again. Go ahead and pause on your side. I'll pause on my side. Go ahead and figure out the frequency for these number of days a week eating fast food. Just now. All right. All right. So let's kind of count through this. So 0 days in a week. So out of these 50 people, how many people didn't eat out in a fast food restaurant at all? So I see 1 there, 2 there. So just 2 people total. How many people ate out once? So I see 1 there, 2 there, 3 there, 4 there, 5 there. So 5 total, it looks like. Good. Etc. So we'll kind of continue. So 2 days a week. 2 of them there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24. That is, you can already tell that's quite likely going to be the winner there. As far as how often did most people eat out at a fast food restaurant? That's out of 50, so that's almost half, 48%, almost half of the people. Let's see. 3 times a week. 1, 2, 3, 4, 5, 6, 7, 8. So 8 people ate out 3 times a week. 4 times a week. 1, 2, 3, 4, 5, 6. It's like 6 people ate out 4 times a week. 5 times a week. 1, 2, 3, 4. 4 people ate out 5 times a week. 6 times a week. It's like nobody in this survey, so nobody ate out 6 times a week. It's like there was 1 person who ate out 7 times a week. So this would be the frequency table or frequency distribution for that data. What do I want to say about this? Oh, so then the question is, how often do most people eat out at a fast food restaurant, and what would be the conclusion here? At least based on this survey, and assuming that this survey is good, represents a good cross section or a valid cross section of the people, and it looks like most people eat out 20 or 24, 2 times a week. So a couple comments about this. So first of all, just about the reality of that. That probably is roughly correct. I don't know. I don't know what your experience has been. I know when I was in college, when I was in my 20s, basically, I probably actually ate out more like 4 times a week. We want to stay locked in. Are you still there? Yes, I am, computer. So probably in my 20s, it was more like 4 times a week. And then for a lot of my 30s, it was maybe once a week. I actually got to a point where I just really cut out a lot of that eating, because it's a lot of salt and it's a lot of oil, and I was feeling the effects in my body actually. So it was like I'm not some super like I do believe in a lot of healthy stuff and a lot of organic stuff. When I say believe, I mean I try to do that stuff, but I'm not a super like, oh my goodness, I have to do it every day or I have to do it all the time, or if I don't do it, I'm gonna die, a slow death early in my life or something like that. But it's true. You need to eat good food. You basically need to listen to your body. You need to eat good food. You need to have a good balance and moderation on things. Um, you know, drink, but don't drink a ton. Eat sugary stuff, but don't eat a ton. Eat salty stuff, but don't eat a ton. Any of that stuff in large amounts just messes with your body on a ton of levels. So for me, I just got taught. I kind of was raised by hippies, and my mom and dad just, especially my mom, was just like, you just listen to your body. Your body will tell you when you've got too much of something and it's messing with you. Anyways, so there was a large part of my life where I kind of cut out um, I cut out a ton of sugar, salt, and oil, which was awesome. My body felt a ton better. Um, but that meant only eating out, once a week, something like that. Um, Now, because of how much food costs, I'm actually probably back to eating out 2 times a week, maybe three, but usually about 2 times a week. That's just pure money. That's like I would like to eat better, but you don't got the money for that. So you guys probably, I'm sure, are experiencing the same thing. The food prices have shot up in the last couple years. And it's just really hard. So even HEB costs a good amount of money even to make food at home, right? It is nice to save money in a couple places, and spending $7 at Wendy's to get a meal is one of those places. So, anyways, so I would say not only in my experience in life, but I would say in general, this is probably very true for the American public, about twice a week. Um, so. Not necessarily true in other countries though. So I got my PhD in Spain, and it's really interesting. In Spain, you rarely actually see any fast food restaurants, period. There's heavy restrictions on fast food there in general because of how much oil, salt, and sugar is put into the food. Um, the other beautiful thing in Spain is they actually basically their food just doesn't contain a lot of the chemicals that ours does. So you don't even want fast food there because you can go down wherever you live. You could go down a couple blocks to the literally the middle of the block and find some local little place that'll get you a nice little lunch or dinner. And just because the food doesn't have all those chemicals in it, it tastes fucking good. Like these aren't even great chefs. These are just normal people going in, starting a business, cooking food, and that food tastes good. It's relatively cheap too. Um, so go to some other countries, you'll actually see that um, they have more restrictions on companies and food because they don't want all those chemicals and extra crap load of extra MSG and sugar in food. But it actually, you feel better. It makes your food cheaper. And random dude down the middle of the street makes a hella good, grilled cheese, right? Like just makes really, really good food. I wouldn't even want to go to Burger King. Anyways, so this is good data, very much an American thing. This is America, not a lot of the rest of the countries in the world. Um, but anyways, so based on this distribution, we would say most people eat fast food twice a week. Another thing I wanted to mention about this, um, notice that again, last time the categories were really words, were flavors, right? But notice this time your categories are numbers, and it is weird to have your categories, your classes be numbers because these numbers, the 0 days a week, the 1 day a week, the 2 day a week, this is not your data. So I want you to realize that your data is this, and we count up the data and we get the frequency here. But these categories are not really your data, right? So what this is saying is 2 people out of 50 ate 0 times a week. 5 people ate once a week. 24 people ate twice a week. So this is actually, the numbers over here is actually the analysis of your data. These are just categories, even though they're numbers. And I think so I say it's a weird thing. I've no teaching, having, taught this class before, quite a few times. I just see students initially kind of stumble with that, or just kind of stumble with that idea of, oh, okay, these are numbers, but these are not my data. Like, this is not, when I'm analyzing it, I'm not using this. These are just categories. These are classes. I'm using this. This actually analyzes my data. So I wanted to sort of throw that out, get you to think about that for a second. You'll see that as we keep going. All right. So like I said, this data sort of had natural classes or categories. Let's look at something like 17 then. So 17, this data shows the maximum wind speeds in miles per hour recorded for 40 states. So this is probably, I don't know if this is maximum over all time. This was maximum in a year. It's probably within a year. So they say this data is from NOAA, the National Oceanic Atmospheric Administration. Basically, this is the organization, this is the federal organization that catches and tracks basically weather data for the whole US. So this is a US organization, and they kind of keep track of all the weather data for the US. So this is likely, it doesn't really say here, so if we went to this website for this, we could get more information about maybe where this data comes from and whether that was over a year or that was all time or something like that. But minus all that, so this is 40 different states, and this is the maximum wind speeds in mile per hour that's been recorded there. I want you to look at this data. And again, this data by itself, we can't do much analysis there, so we're going to start by making a frequency table or frequency distribution out of it. But now what I want you to think about is, for this data, what are my classes? What are my categories? What would naturally be the classes or categories that I would use here? So what are your thoughts? And you may be thinking that there's an answer to this, but actually, so if when I said, what are your thoughts? If your thoughts are, well, I don't actually know, like there isn't anything there that tells me sort of a natural category like there was on the last one, 0 days, 1 days. Here you're just getting a bunch of random miles per hour, right? So 59 miles per hour, 78 miles per hour, 62. There's no clear cut, like, I should look at my 40s and 50s, or I should look at certain, certain miles per hour. There's just no clear cut categories. With a lot of data, so with a lot of quantitative data, that unfortunately is the situation you're always going to run into. That for stuff like this, there is no clear cut categories. There is no clear cut classes. And so what we're going to do on this problem, and what we're going to do on a lot of these problems, a lot of the rest of these problems, because a lot of data that we actually get is more like this, is we've got to, the problem might tell you how many classes or categories to do, or we might decide ourselves how many classes we're going to do, but we got to figure out kind of how many classes we're going to have, and we actually have to create the classes ourselves. So I really want to take this problem. So we're going to end up with the same thing. We're going to make a frequency table. But in this case, there is no clear-cut category, so we're going to have to construct the categories or the classes. So I want to show you kind of the process for doing that. And then you'll see there's several problems that they give you in this section that are just variations of that. So sometimes they tell you how many classes they want to be there. Sometimes they tell you where the classes should start. So they just get you to have slightly different ways, entry points basically, to constructing these classes or these categories. So, okay. So this problem says they want 7 classes. So they're gonna want 7 categories. 1, 2, 3, 4, 5, 6, 7. 7 rows. So the question is, if there isn't any obvious category or classes, how do I construct 7 categories, 7 classes? So what we're gonna have to do, we're gonna have to do a little work on the side here. So we're gonna kind of try to construct 7 classes. The first thing we're gonna do is we're gonna figure out the lowest number and the highest number. So one way to think about this is if there isn't any obvious categories, then one thing we can do though is we can imagine that all these wind speeds, we can imagine all these wind speeds in some sense, instead of in a square like that, in a line from lowest to highest. So one way to construct those categories is if I know the lowest and I know the highest, then I just need to split that space, that distance from the lowest to the highest into 7 even natural categories or classes. Again, so we're gonna start using the word classes. So 7 equal classes. Literally just 7 equal spaces. But in order to do that, I need to know the lowest and the highest. So what is the lowest number that you see here? Give you guys, and actually, so I'll give you guys a second. This time I won't pause on my side, and you can pause if you want to, or you don't have to. But I'll give you a second. Just figure out the lowest and the highest number. So looking at that data. I'm gonna erase this too for the moment. Lowest and highest. What do you guys see? So for the lowest, what I see is 53. Looks like that's the lowest. And for the highest, I see 93. Should have split this into 8 classes. A second, I just want to make sure I didn't miss anything. Oh no, we do have a lower. That's fine. Sorry, guys. This also helps when I actually have a class here. So when I make mistakes like that, usually somebody catches it, shouts it out. So it looks like there's a 48. Anything lower than that? I don't think so. So actually, the lowest is 48, the highest is 93. Okay. So again, the idea is then to construct my 7 classes, what I'm going to do is I'm going to split distance from 48 to 93 into 7 equal parts as best as I can. So first of all, how far is it between 93 and 48? How would you figure that out? So to figure out the distance between them, I just need to subtract. That's actually something you're gonna keep seeing as we go throughout the class. Anytime, and if you haven't thought about this before from a previous math class, anytime you need to know the distance or the amount between one number and another, you subtract. That's actually what's one of the main things that subtraction does. It's sort of one of the main uses of subtraction. You subtract one number from another, it tells you the distance between them, right? Whether that's horizontal distance, vertical distance, it doesn't matter. It just tells you the amount between them, the distance between them. So we're just going to subtract 93 minus 48. And what is 93 minus 48? That should be 45. Now, when you take highest minus lowest, so again, anytime you subtract, it gives you the distance between things, but the distance from the highest to the lowest in statistics is called the range. In this case, that is 45. The range is 45. Second, let me write this in a different place just so I can see if I'll work on. So that distance in between is my range, and that's 45. So now what I want to do is I want to split that distance between that 45 into sort of 7 equal parts. So then what operation do I need? What would I do to split 45 into 7 equal pieces? Good. So splitting things into equal pieces, that's what division is. And that's actually the definition of division. But just like I said, the main purpose of subtraction is finding the distance between things. The main purpose of division is splitting things into even pieces. That's what division is. So then the idea is I want to take 45 divided by 7. When you take 45 divided by 7, what do you get? And this doesn't split evenly, so this actually you're gonna need a little either a calculator or maybe you can do kind of the fraction work in your head, but you'll need a little something to help you get this answer. 45 divided by 7, 7 times 6 is 42. So this is going to be 6 3/7. It's a little less than 6.5, or you might see on your calculator, I think it's like 6.42 and then a bunch of decimals after that. So if I wanted to split this distance from 48 to 93 into 7 equal parts, I would need every part to be 6 3/7. Now, practically, we're not gonna split it to exactly 6 3/7 because then it would be hard to write the numbers. So what you're gonna do once you get this number is you'll always round it up. So when I say round up, I mean whatever the number is, don't round it normally, like up or down. I'm saying just auto round it up to the next whole number. So 6 3/7, if you round it up to the next whole number, what is that? Good, that's 7. So to get my classes then, again, I'm splitting this into 7 equal parts. Let me try to. Then that line goes a little farther. So this should 1, 2, 3, 4, 5, 6, 7. So that's 7 spaces there, 7 equal parts. And then all you're gonna do, so we said we rounded this up to 7. All you're gonna do then is 48 plus 7 gives you the beginning of that next class. So each class is gonna be like the first class is gonna be 48 up, basically up 6, but it's gonna be 48. And then the next class is going to start 7 later. So again, the whole purpose of this was just to tell you, we want to split this into 7 equal pieces. So once I figure out this by the way is what's called the class width, and we'll talk about that, but that's the term they have for it, the class width. That just tells you how to count to the beginning of up this number line to the beginning of the next class. So like 48 plus 7 is 55. 55 plus 7 is 62. 62 plus 7 is 69. 69 plus 7 is 76. 76 plus 7 is 83. 83 plus 7 is 90. And then 90, that last class would go actually up to 96. So this gives me my way of having 7 classes, 7 categories that roughly evenly split this space between 48 and 93. Hopefully that idea makes sense to you. So for my frequency, this table, my frequency distribution, so let's see. So now my categories, my classes are about wind speed. So my first class is going to be 48 to 54, to the number right before that. So it's going to be 48, 54. So the first category of wind speed is a wind speed between 48 and 54 miles per hour. Then my next class is going to be 55 to right before 62. And what number is right before 62? It's 61, at least if we're talking about whole numbers. So 55, 61. And etc. We can keep going. So then the next class is 62 to what? It's gonna be 62 to right before 69. So 62 to 68. And then the next class is gonna be 69 to right before 76. And what's that gonna be? 69 to 75. And then you can kind of keep going from there. You can get the rest of the classes. So that's what I'd like you guys to do actually is this won't take long, but I do want you to pause for a second. So we have 4 of the classes. We need 3 more classes. So write the other 3 classes for this really quick. So these other classes then. So we had 69 to 75. So what's the next class going to be? 76 to 82. Then the next class is going to be 83 to 89. And then the final class is going to be 90 to what? So this last class that you make is always going to be it's maybe the most interesting one, which by interesting, I just mean you got to give it a second of thought. Because notice that all of the classes that you created before this, so 48 to 54, if you think about that, what is 54 minus 48? That's 6. So this class covers 6 numbers, 48 to 54. This class covers another 6 numbers, 55 to 61. So if you think about it, 61 minus 55 is also 6. 68 minus 62 is also 6. So by saying that each of my classes has width 7, what I'm basically guaranteeing is each of the ranges of numbers here is 6 across. 75 minus 69 is also 6. 82 minus 76 is 6, etc. So the reason I'm bringing that up is this last class starts at 90, but if my table that I'm using to make this analysis is going to be fair and accurate, I need this last class to also be 6 long. Basically, is one way to think about it. This last class can't be shorter than the other classes. They have to have an equal length, equal width. So that's one thing to know about frequency tables and distributions in general is, again, to be a fair analysis so that, because what we're going to end up doing here is we're going to count how many states had these wind speeds, and then we're going to compare the results, right? So to compare these, if you're comparing 2 things, the categories have to be like each other, or else you have an inaccurate comparison. So if this was 90 to 93, that would only be 4 long. So then for instance, there would naturally be less states in that category than there would be in a category or a class that's 6 long, because 6 is greater than 4. And then it's not a fair and accurate comparison. So once we're dealing with quantitative data, you have to make sure that your classes are the same length all the way down. So this last class then is going to be 90, not to 93, but to what number? Good. It has to be 6 long, so it's going to be 90 to 96. And these are my 7 classes, my 7 categories that I'm going to then count and sort my my states into, or my wind speeds into. So I want to go back, like I said, there's some vocabulary that we need. Once we have classes that are like this for quantitative data, there's some vocabulary that they're going to ask about or they're going to reference in your homework. So there's some vocabulary we need to talk to, and I want to do that. But first, I want you to actually finish this out. So now that we have our classes, you can count how many states fit each category, each class. and then make a good comparison. So again, I'll have you pause on your side and go ahead and count everything out, count your frequencies out from here. Let's see what you guys got. And I'll do my own count as we go. So states with a wind speed somewhere from 48 to 54. So including 54 is what we need here. So 48 to 54. Like nothing there. Nothing there. Nothing there. Nothing there. There. 1, 2 there. 3. It looks like 3 states. So 3 states had maximum wind speeds from somewhere between 48 and 54 miles per hour. Then the next one is going to be 55 to 61. So let's see, that's 1 there. 61, 55 to 61. 1 there. Like 2 there. Only 2 states is what I'm seeing. Right, and then 62 to 68. So let's see, 62 to 68. I see 1, I see 2, I see 3, I see 4, I see 5. Six, 7, 8, 9. So I see 9 total states that have max wind speeds from 62 to 68. So there's sudden kind of just a couple states 48 to 54, a couple states 55 to 61, and then we have a sudden spike to 9 states, 9 states at 62 to 68. 69 to 75. All right, so let me keep counting through these. So give me a second. 69 to 75. It looks like then we have 1. Yeah, 69. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13. So it looks like 13 total states from 69 to 75. So this 9 here is not just a spike. Now we have sort of a trend of a lot of states sort of in this middle range. Let's look at 76 to 82. So 76 to 82, it looks like there's 1 there. Then there's 2, 3, quite 3, 76 to 82. 4, 5, 6, 7, 8. Looks like there's 8 total states from 76 to 82 miles per hour. So notice again, so it wasn't just a sudden spike, then we had kind of a peak here from 69 to 75, but then it's coming down almost the same amount on the other side. So I mean, again, there's quite a few states that are 76 to 82, and it's kind of mirrored, it's almost like the 62 to 68 category. So what I'm doing is I'm kind of comparing and contrasting these numbers as I go. What we're gonna see, especially starting in the next section, is we can turn this into a picture, and the picture is gonna have a shape to it. And so I'm starting to talk about the shape of this distribution, because then that shape will help us analyze, again, in this case, you know, we need to organize this data, get a shape, we need to analyze it, because again, maybe we're the National Oceanic and, Atmospheric Administration, we're the national weather men and women, and we need to get something out to the public saying, like, I don't know, just general warnings for wind speeds, or maybe we need to get something out to another part of the federal government that regulates manufacturers on, how well they got to manufacture things. So if you think about this means so far that we at least want to make sure, honestly, that a lot of structures that we're building can handle 82 mile per hour maximum wind speeds, like short bursts of 82 mile per hour wind speeds. Because up to 82 miles per hour seems to happen quite a bit, right? Um, so, um, or we need this data to feed into a model so we can sort of get for instance, literally they can create like a map essentially of wind speeds around the US. So again, we need to be able to start thinking about the shape of this data so that we can do some analysis with it. So, but anyways, 83 to 89. Like 1, 2, 3. It's like maybe 3. Did I missed one. I feel like I missed one. Maybe not. And then 90 to 96. 1 here. 2 here. Looks like maybe just those 2. You'll notice that very much again, if you sort of pictured this in your head, almost using the numbers as like a height or a bar, which in the next section we're going to call a histogram. So when you can turn this into a bar graph, and they call it a histogram. But if you imagine this, it's almost, again, it's kind of low on sort of the left side and the right side, or sort of the low speeds and the high speeds, but it's almost mirrored. And then again, the 62 and 68 and 76 to 82 is almost mirrored, and then we kind of have a high value, or high number of states in the middle. Let's see, there's 50 states, so let me also make sure this adds up. So 5, 14, 27, 35. Oh wait, or did they only do 40? Oh, 40 states. They did 40 out of the 50. Okay. That works, but that does work. So there's a good frequency table. So like I said, there's a bit of vocabulary and things they want you to be able to identify. So we'll use kind of this table that we just built for that. So one of the things they're going to ask once you have kind of classes like this that are, little ranges of numbers, they're going to ask for something called the class width. Basically, how far is it from one class? And the way you want to think about it is it's actually not the length of the class, like I was saying, it's how far is it from one class to the next. And so you can use either the beginning of the classes or the ends of the classes, it doesn't matter, but you just basically want to know how far is it from one class to the next. So how far is it, for instance, from 48 to 55? Good. That's 7. And notice that that continues all the way down. 55 plus 7 is 62. 62 plus 7 is 69, etc. In fact, we kind of constructed it that way. But that tells me that the class width is 7, and that's one of the things they're going to ask for. Another thing that they talk about is the midpoint of these classes, and then also the boundaries on the classes. So let me what I'm gonna do is we literally are just gonna add these two, I'm gonna add 2 columns to this table, to this frequency distribution, and just outline kind of what they mean, what the boundaries are for the classes, or what they call class boundaries, and what the midpoints are. So, and on some, the reason I'm gonna add it onto the table is on some tables, they do show it that way. So they'll show you the classes, but then as they'll actually have 2 extra, 1 or 2 extra columns, depending on what they want to show you, but they'll have 2 extra columns in between, one that shows class boundaries, one that shows, what do you call it? Sorry, midpoints. In fact, let me actually, I'm gonna do it that way. I'm gonna kind of reproduce the table over here, but I'm gonna put 2 columns in between with other information they want, they want you to figure out or know. So wind speed. These will be my classes for that. Then they'll have, they're gonna have one that says, it should say class boundaries, but to save us a little room, I'm just gonna say boundaries here. But that's what they mean. There's the boundaries on the classes. They're gonna have a column, or they'll want you to figure out the midpoints of the classes. Or they'll say class midpoints, and then we'll have our frequency to column. This, I don't think you can see anymore, so let me move camera. So what I'm gonna do, let me rewrite the classes that we figured out. So our classes were 48 to 54. They were 55 to 61. 62 to 68. 69 to 75. 76 to 82. 83 to 89. And 90 to 96. Actually, give me a second, I'm gonna check on something. You'll see this often. Sometimes I have to check on, so like I said, I've statistics in particular, the definitions for things have slightly changed over the years, and you don't, like I said, you don't see it as much with algebra. But with statistics, it tend to be, because you'll see as we go through statistics that some of the things they're asking you to kind of, especially when we talk about presenting, graphing the information or presenting it to a reader, There's some subjective things there. It's not, again, it's not always going to be like algebra where there's a definite answer and a definite way to do it. There's some subjective things there. So because statistics is more subjective, like I said, first statistics class I took was probably in like, I don't know, 2002, and I'm teaching you now in 2025. And I've seen them change the words they use, or I've seen them change definitions slightly over the years, whether I was taking a class or whether I was teaching a class, depending on the textbook I was using. And so it's really kind of interesting. The concepts and ideas are the same though behind them. They just sometimes use a slightly different definition or a slightly different word, but the concepts and ideas are the same. So again, as we go through, I want to pay attention to some of these vocabulary for you just to get you guys so you can read it and know what they mean. But I really want to major on the concepts and ideas because the concepts and ideas are always the same. So if I can get you to major on the concepts and ideas, then you'll see that you almost don't even need the vocabulary. So anyways, but yeah, let me look at the definition that might have changed in this book compared to another. Oh, do it now. Suspect of 17. All right, so the boundaries. So the idea, like I said, it's what they're saying there's class boundaries. And so you want to think of each of these classes almost like a plot of land. So this plot of land goes from 48 to 54. This plot of land goes from 55 to 61. The idea of boundaries is you need a little cushion outside of that plot of land or that little length. Because what we're trying to do, so the data you're given here is all given in whole numbers, right? But what if we tested the 41st state? And on the 41st states, let's say the wind speed they got was, I don't know, 54.7 miles per hour. So looking at these classes, the question is that 41st state, which one of these classes would that fit in? If the wind speed reading that I got was the maximum wind speed was 54.7. And I actually want you guys to think about that for a second. So take a second, you don't have to pause, but take a second and think about that. Where would 54.7 miles per hour fit in to our classes? So what do you guys think? And notice that there's not sort of like a definite, there's not a definite answer here, right? Because this class goes from 48 to 54, and then this one starts at 55 and goes to 61. So anything between 54 and 55, I kind of don't know which one it should be part of. But there is a practical, you probably also then started thinking about, well, practically, intuitively, which one should it belong to? It should belong to the second one because 0.7, that 0.7 is 54.7 is closer to 55 than it is to 54. So if you think about rounding, basically, if you think about, basically if you think about rounding, then anything that's 54.5 and up is going to be closer to 55, or we're going to consider it 55. It would round up to 55. Whereas anything up to 54.4 or, 54.49 or 99, etc., that would round down to 54. So these boundaries are basically, the class boundaries are basically just about being explicit about which, basically, if the data you're given is like one decimal place longer than what you have here, it just shows you the rounding. I guess the best way that I think about it is it just shows you the rounding that you kind of already know, but it shows you the rounding that you should do to figure out which class these numbers go in. So if I'm given some wind speed, anything 48.5, or sorry, 47.5 and up, it's gonna round up to 48. So my boundary first class starts at 47.5. But then when I get to 54 miles per hour, I can go all the way up to 54.4. And when I round, that's still going to round down to 54. And therefore, a state with 54.4 mile per hour wind would fit in this class, the first class, not the second class, because 54.4 rounds down to 54. So the boundaries for that first class are 47.5 to 54.4. Actually, again, let me check on this. There's a couple of books that write it differently. I don't think this is one of them, but let me check. Yeah, this is one of them. Damn it, I hate it when they write it this way. I don't think it doesn't make good logical sense. Okay, so let me alter this slightly. What I was telling you, so I was telling you before, the concepts and ideas behind it are the same, but they write it a little differently depending on the book. So what I was just saying there is the concept and idea behind it. So if I get another state, I'm gonna put it in this first class as long as it is anywhere between 47.5 to 54.4. And this second class, again, a wind speed would fit in that second class if it's anywhere from 0.5 below this, so 54.5. So then at 54.5, we start rounding up to 55. And then out to where? So what would the largest decimal, basically what would the largest number be that still rounds down to 61? Good. That would be 61.4. So what boundaries do is it enlarges your classes to just basically the decimals that you would still round into that class. Now, what this book does, which several books do, which I don't like, honestly, is so, like I said, this is the correct idea and concept behind it. However, notice that by doing this, so just like our classes originally, notice our classes originally go 48 to 54, and then it's 55 to 61. So counting wise, 54, the next number is 55. But if you think about it in terms of like a ruler or distance, there's some space between 54 and 55. So the same deal here with these boundaries. Notice that there's some space between 0.4 and 0.5. So like the first boundary ends at 50, would normally end at 54.4, and then the second boundary begins at 54.5. So this is a correct way to write this in some of the books. But in this book, they don't like the fact that there's space between this 0.4 and 0.5. So in this book, they emphasize this idea of the boundaries should be continuous. Like basically there should be no gap between the boundaries. They should meet each other exactly. So because of that, what they do in this book and a couple other books is they adjust this boundary so that it goes up to 54.5, so that it basically literally meets exactly at the next boundary. And so then this 61.4 would actually go to 61.5. Now, mathematically, I don't agree with that, but it does. The reason they do this honestly is not because it's mathematically correct, but because it looks nice. It gives you a clearer picture that these two boundaries kind of actually meet each other. So again, once we get to the next section where we start turning these into pictures, you'll see that when you see a picture of this data, when you see a graph of this data, you do want your classes to meet each other. You want them to be right, to just hit each other, because otherwise that gap that you can imagine, but say between 54 and 55, that will be a gap on your graph. You don't want a gap on your graph. You want to, if you're drawing a picture, you want it to scan from left to right and have no white spaces, no holes, right? So when we turn this into a graph, when we turn it into a picture, I don't want these spaces, which is why it's nice that these match each other. But mathematically, they shouldn't match each other because like we were talking about, what they're really trying to do here is just say what numbers round into each class. And 54.5 rounds up to a 55. So just know that this is one of the first places in statistics where you're going to see. So like I said, algebra is very logical. It's just the answer is the answer. The methods are the methods. In statistics, there's what do you call it? Not only some subjective stuff here, but basically they take into account the fact that we're gonna have to create pictures with this. And so they take into account the things that humans need aesthetically in a picture. Things that we need aesthetically, aesthetics is not logic. Art is not logic. Both show beauty and truth in a different way. They show patterns to reality, but art is not logic. Art requires some aesthetics. Aesthetics are subjective. So anyways, so you're gonna start to see these little things that they do that are not math, they're aesthetics, but there's a reason for them. And so we include them in a statistics class. Anyways. So for each of these classes, then I can write the class out using class boundaries instead of the way we wrote the classes originally. I just need to make sure that my boundaries meet on each side. So for instance, what would the next class be using boundaries? So this 62 would go down to 61.5, so it would meet that 61.5. And then it would go up to 68 plus 0.5, so that's just 0.5 after that, so up to 68.5. And then that 68.5 now matches or meets 1/2 below 69, so this next class would be 68.5 up to 1/2 after 75, 75.5, etc. And you would do that all the way down. So let me have you guys actually write out the rest of these classes using boundaries or the rest of the class boundaries. So just pause really quick on your side. I'll pause on my side and write the last three out. All right, so then these last three. So this next one would be, what did you get there? Good. That should be 75.5 to 1/2 above 82, so 82.5. And then what would the next one be? 82.5, 89.5. And what about the last one? 89.5 to 96.5. Those would be then the class boundaries. Now let's talk about the midpoints. And you've actually seen midpoints before in like an algebra class. So I want you to think about not the equation you use for that, but I just want you to think about what midpoint means. So literally, what does midpoint mean? It means the point in the middle, right? So we need to find, so midpoint is always what you're saying is I have 2 points and I need to find the point halfway in between. So that's the same idea here. For each class, we basically want to figure out what number, what point is halfway in between. And so how do you find, so then now you want to think about maybe not an equation, but you want to think about how do you find the number halfway in between two numbers? So we know if we have two numbers, if you subtract them, that gets the distance. But how do we find the value halfway between? And so if you didn't pick this up in a previous class or just kind of notice this as a pattern, so not only here, but you'll see every time in this class that we need a midpoint, because midpoints apply to things other than classes, we're going to do the exact same thing. And in fact, this is what you did in algebra. So if you want to find the middle points, the middle of two things, you always add your two values together and divide by 2. So you add the two values, so you sort of get this super big value, super combination of them, and then you divide by 2, and that'll automatically take you to halfway between the first and the second number. So add the 2, divide by 2. So for instance, if I want the midpoint for the class from 48 to 54, I'm going to add 48 and 54. If I add those, what do I get? So I will write this out. I'll kind of write the calculation out once, but then I don't want to write it out every time. I'm going to add those. And when you add 48 and 54, that gives you 102. And I'm going to divide by 2. And what is 102 divided by 2? Good, 51. 100 divided by 2 is 50. 2 divided by 2 is 1. So 51. So for that first class, 51 literally is the number halfway between 48 and 54. And so that's all a midpoint is in terms of our frequency tables, is you're just gonna identify the point that's halfway between the ends of your classes. So let me see if I can get you guys to do that for all the other classes. So pause on your side, I'll pause on my side. 51 is the midpoint of the first class. I did that by adding the 2 and dividing by 2. So I just want you to do that for each of the other ones. All right, so easy enough. So 55 plus 61, oh yeah, let me need that all way to go away. So 55 plus 61, when you add those, you get 116. You divide that by 2, you get 58. So the midpoint for the second class is 58. From 62 to 68. They add together to give you 130. Divide that by 2, you get 65. 69 plus 75 is what, 144. You divide that in half, you get 72. So the midpoint would have been 72 for the fourth class. For the fifth class, 76 and 82 is 158. Half of that is 79. 83 and 89 is 172. Half of that is 86. Then between 90 and 96, 86. The half of that is 93. So those are the midpoints of each of my classes. So that's a good way to calculate it. I do want you to notice that, so when you were doing these too, so if you tend to have, if the way that you kind of see things, especially the way that you think through things is more visual, you see pictures in your head kind of as you go, then you may have noticed that you kind of didn't actually need this formula, because if, let's think about, go back to the first class. We're saying 51 is halfway between 41 and 54. And if you think about that, that makes sense, because 48 plus 3 gives you 51, and then 51 plus 3 gives you 54. So 51, if you think about the number line, you could have figured out that that was the number halfway in between, because it's just 3 to the left and 3 to the right gives you the ends, right? And so the same for 58. 55 plus 3 is 58. 58 plus 3 is 61. So if you're more of a visually oriented person, you might have actually been able to actually just think about the number line between these numbers, like 55 and 61, and you can almost actually just see the number halfway in between. And if you can do that, then you should do it that way. You shouldn't do the formula. Because then the formula is way too overly complicated and unnecessary for you. If you're not very much of a visual thinker, you are going to need the formula, because you just don't see that picture in your head, and that's fine. We're all different types of thinkers. We'll kind of talk about that as we go through the class. I usually talk about that in any of my math classes. You've got to figure out what type of thinker you are, kind of in multiple facets. And whatever type of thinker you are for a particular facet, like figure out the type of thinker you are, and then run that mode to death. Like take advantage of that. So one of the facets, or one of the ways that we, like when we psychology, we study the way people think. And even me just seeing it, even if I'd never studied psychology, if I just watched y'all students and just kind of looked at how you thought through stuff. Some people are visual thinkers. Some people are kind of verbal / symbol thinkers, like numbers. So it's like, so some of you don't see many pictures in your head when you're thinking about things, but you see letters left to right. You see the equations kind of laid out left to right, or maybe up, maybe down to up, but in some direction. And if you're that type of thinker, that means that you're usually much more of a procedural thinker, and you kind of need a formula, you need steps. But the nice thing about that type of thinking, though, is once you have the formula, once you have the steps, you just run it to death. You run it every time and it gets you the answer, like we saw here. So if you were that type of thinker here, then You were in your comfort zone. Every single time you just added the two numbers divided by two, and you were like, this is brilliant. You were applauding yourself. This is freaking awesome. I just got to add the numbers and divide by two. But some of us, when we think through, so about half people are, I don't know, I forget the word, the term they have for that, but half of us are more word symbol oriented thinkers. But half of us are visual thinkers. We actually don't see words a lot in our head. We see pictures of what's going on. And we use those pictures to actually help us analyze kind of what to do. This is sort of a general truth. This is not true for every individual person, but visual thinkers tend to be better gamers because and you're playing, you're playing a game. I'm probably showing my age here, but playing Halo or Skyrim or now Fortnite and all this stuff. But all of these things are completely just pictures. It's visually saturated, and you need so as gamers, people who think visually tend to be better gamers because what you do as a visual thinker is you just take the situation and you sort of rotate it around in your head and you figure out a way to get to the answer. It's like you essentially, in some ways, are figuring out your procedure every time. So again, procedural thinkers want one way that works every time. And once they get that, they rejoice and they just run that ish to death. Visual thinkers like having games to solve. And so they don't want a procedure because I don't trust the man. Who says that procedure works every time? I don't trust the man, but I trust that I can figure out the little game that's put in front of me, right? The little problem that's put in front of me. So visual thinkers will not trust a procedure. What they will do is actually find a different procedure sort of every time, but it's just based on they visualize how the problem works. And if they can visualize how the problem works, then they don't need a procedure. You just play your little game every time. So whichever type of thinker you are, major on it. So if you need the procedure, find that procedure and run it. If you're a gamer, make a picture of this in your head and just find the number that's halfway in between. And your head will do that very quickly every time. You won't need the formula. So whichever way works better for you, run it. Good. And then we can finish off this table just repeating the frequencies here. So this was 3 states there, 2 states there, 9 states there, 13 states there, 8 states there, 3 states there, 2 states there. This is actually a perfect place to stop, so I'll kind of off of what we see there. So again, going back to us talking about analysis. So again, if you're the NOAA, and you're trying to recommend to the president or you're trying to recommend to some state board, if you're gonna have somebody build houses, what wind speed should we make sure that they can they can withstand? You might take this data and say, well, you could just say, just go full bore, 100 miles an hour, 96 miles an hour. But one of the things that always happens is, so if you tell every builder that they gotta make it withstand 100 miles an hour, those houses then become crazy expensive, and the supplies, the materials to make those houses you need a lot more, and you need a lot better materials, right? So the NOAA is not gonna say 96 miles an hour, but they're probably gonna say up to about here. They're gonna say we can't say full. We're going to allow some deaths eventually, but we want most deaths not to happen, right? So we're going to cap it at 82 miles per hour, and we're going to suggest to the state boards that, if the builder doesn't make it withstand at least 82 miles per hour, then they shouldn't get a permit to build in that state, right? To work in that state, etc. So that might be the conclusion from something like this. All right. Second. The next thing that I want to kind of add on to this table, so I would still want to stick with the same information that we have from the last problem. I think it's 17 that we were working on. There is, what I'll say is it's not another type of table, but we've been doing a frequency distribution table. They also might ask you to do a cumulative frequency table, cumulative frequency distribution for this data. So they literally, it's frequency distribution, they just add the word cumulative in front. Let's think about what the word cumulative means. So what does the word cumulative mean? And maybe you have an idea that what that word means and maybe not, but what do you guys think? What does it mean? So to cumulate means to accumulate. It means to add things up. It means to basically see how much total that we have so far. So the cumulative basically means a cumulative frequency table is a table that tells you how many, what do I call it? Give me a second. You're gonna count how many of your data points fit now, not a single class, but that class and everything before it. So you're literally gonna add up everything kind of before it as you go. So I kind of accidentally stopped at a good place in the book. Here's an example of what a cumulative frequency table looks like. So notice the classes. So now no longer am I saying 48 to 54. I'm saying everything less than, right, 54. And then for the second one, I'm saying no longer am I saying 55 to 61. I'm saying everything less than 55 to 61. So just to kind of show you then how this works, let's build a cumulative frequency table for this data that we already have. Thing is, there's well, okay. Hopefully you guys can kind of read over. I know it's gonna have all these, the words or the sentences in the background, but I think the way this looks on camera, you can still kind of read over it pretty well. So if they wanted a cumulative frequency distribution for this data that we were looking at with the wind speeds, what you would do is yeah, let's just do what we should. So my title here is still going to be wind speed for my classes. And I'm still going to have frequency here. Although oftentimes what they'll say here is they'll say cumulative frequency. It's a little redundant to say that, but let's write it. Cumulative frequency. Now, when we write our classes for a cumulative frequency table, you're not going to say 48 to 54. You're going to say everything less than 54. The second class, like I said, is now not going to be 55 to 61, just the two states from 55 to 61. It's going to be all the states that are less than 61. So it's going to include the 55 to 61, but it's also going to include these three states that are 48 to 54, which is less than 61. So the idea, again, the idea of I gotta write smaller here. The idea of a cumulative frequency table is we're trying to describe how many total states kind of fit up to a certain number rather than how many states fit in a certain class. So we'll have less than 61. The next row will be less than 68. Less than Jake, sorry, good band. And etc. You can kind of go from there. So what would the next row be? That would be less than 75. And then what would the row after that be? The number of states less than 82, etc. You guys kind of get the idea from there. So the next one would be less than 89. The last one would be less than 96. Then, because again, this is cumulative frequency, I mean, I'm still just really what you end up doing is you still just count how many fit the category. But the category now is everything it's less than that number, so it's everything above it. So, one good way to do a cumulative frequency diagram, if you already have the frequency, is you just start with, so less than 54 is gonna be, there's 3 states. But then less than 61 is now gonna be those 3 states plus the next 2 that are up to 61. So now less than 61, the cumulative frequency is 5 states. So then what would 68 be, less than 68? That would now be these 9 states plus the 5 before it, so that's now gonna be 14. So it gives you, again, kind of a running total of everything up till then. What about less than 75? So now it's all 14 of these plus the next 13, so that's 27. What about less than 82? So that's now all 27 plus another 8, that's 35. Less than 89. 35 plus 3, so 38. And then less than 96, that is all 40 states. So pretend this column, wording on that column is much shorter, but that would be your cumulative frequency column for this data that we started with wind speed. And when you're analyzing data, actually cumulative frequency tables come up more often than you'd think, but especially when we start looking at pictures of this data, when we start turning this into graphs, which we'll be doing in the next section. Good stuff. So let me go back. So that's everything from 17. Everything they like to do in this section, I guess, from things like 17. Would if this was a class, I think what I'd do is I'd probably give you guys another one to kind of like just dissect. I kind of took you through how to figure out those classes. But I think for sake of time, surprisingly, these lectures take me longer than if I have students in front of me. Because when I have students in front of me and people are interacting with what I'm saying, I actually think and go through the stuff quicker. So anyways, I think for sake of time, like that's good enough. So that one example, that kind of gets you how to build those classes, how to figure out the class boundaries and the midpoints, and then the cumulative frequency if you need to. So that kind of does everything we need it to do there. So let me erase this then, and we'll just look at a couple more problems. A couple more problems that they have in this section that just kind of test some of the ideas we've been talking about. Erase. All right. So let's go back to these questions like the following. So they say exercises 9 through 12 here show frequency distributions that are incorrectly constructed. So we already saw, so I sort of mentioned to you guys one way that we can like wrongly make a frequency distribution or to like incorrectly create the frequency distribution. So the thing that we saw was your classes have to be the same length or width. You have to have even space in your classes. basically in order to have a fair and accurate comparison of kind of the different categories. Another one that I kind of talked about, but I didn't name it to you, is when we were talking about the boundaries, we were kind of talking about we need our classes to meet each other, right? So normally our classes look like they have a space between them. So if you look at the class limits, so like on the last one, you had the first class ended at 54 and the second one started at 55. So when you're using counting numbers like that, that we consider that to be they meet each other, right? Because if you're counting, the next number up from 54 is 55. There's no real space there. If you're thinking about a ruler, sure, there's space there. But if you're counting, the thing out of after 54 is 55. So the other thing that we need for the classes, the classes that we construct for our frequency tables is they need to, what do you call it? The classes need to sort of meet each other. That also means that they can't overlap. So we can't have one class, like let's say on that last table that we did, let's say that first class ended at 54. Well, if the second class starts at 53, well, that's a problem. Because then I might have a piece of data, or I might have one of the states that fits into both of those classes. And that, again, that doesn't work. That just makes my diagram and the counting not accurate and not work. So we can't have our classes overlap, but they do need to meet each other. They need to be counting wise, the end of one class, the next number should be the beginning of the class after it. So there's a couple things you have to make sure about these classes as you go. So 9 through 12, what they're saying is all of these have some mistakes. So somebody went and made these frequency tables and they made a mistake in every one of them. And so it's your job to kind of find the mistake. So I actually want you guys to do that. We don't have to do it for all four of them. Give me a second. Let me just figure out which ones are maybe more important to see. Basically, I'll have you do 9 and 11. So take a look at 9 and 11 for a second. And then see if you can figure out the mistake that the person who made these frequency tables made for each of them. So you can go ahead, we can do the usual. You can pause on your side, I'll pause on my side. Get rid of the infinite all. All right, so what did you guys say? What do you think? So on 9, what's the mistake? And on 9, at least maybe at first it's kind of hard to see, but notice on 9, so that first class is kind of 9 across, right? 10 to 19. So is 20 to 29, that's 9 across. But then 30 to 34 is only 4 across. So is 35. 35 to 45 then is like 10 across. 46 to 51 is 5 across. So these last 3 classes are all wonky and all over the place. They don't match the first 2 classes as far as how large those classes are. So that's the problem here. What about 11? Notice on 11, the lengths of our classes do match. Everything is 2, technically 3, but everything is 2 across. 2 to 4, 5 to 7, 8 to 10, 4 to 6, 7 to 9. But what's the mistake here? Good. So notice that 162 to 164, after 164 is 165, so we're good here. 165 to 167, after 167 is 168. But the problem is here. This one ends at 170 and then this one picks up at 174. This one should pick up at 171, and it doesn't. So there's that gap there. It's not continuous. So the word they're using there is continuous. So that's the mistake in that one. Good. Okay, so those are some pretty common mistakes that you'll see. You'll have some questions that do the same thing. They ask you to identify the mistake. Good. And not only should that get you everything for section 2.1, but that's a good introduction to, again, somebody gives you data, the first thing you need to do is be able to organize it. And the best first way to organize things is actually a table. So we call it a frequency table because you're gonna have these categories or classes, and you're gonna count how much of your data fits into each class or category. But that's all it is. So we need to organize our data. We do that into a frequency table. And the frequency table, you'll notice also, even though we haven't done any graphs, it already sort of gives you a picture of the data. So you can start to analyze the data. What thing happens the most? What's sort of the picture of the data, etc. Good. Okay. All right, so that's good. So I'll come back for the next video, and we'll look at, we're literally just gonna take this and take it farther. And we're gonna turn it into some graphs, but we're gonna take frequency tables. So you're still gonna do a frequency table in section 2.2. We're just gonna turn it into some graphs. So I'll see you then.